Now, the technology showcase is happening. We've had a couple of them already the last couple of days, and they never fail to deliver. Frithjof Hennemann is back with us to moderate that. The floor is yours.
Thank you, Terry. Yeah, good day, good afternoon, good evening, dear audience from wherever you're joining us. This is the final session on technology showcases, and I'm pretty much looking forward to this one because they will present us some of the new technologies developed in the case of UXO clearance. And as a first speaker, I would like to introduce Dr. Peter Menzel from Fraunhofer IGD, Institute for Computer Graphics. Peter has a background in physics with a focus in fluid mechanics, and he has worked several years in physical oceanography at the Leibniz Institute for Baltic Sea in Warnemünde, and he is involved in UXO-related research already back since 2011, and will today represent to us and present us the digital OceanLab, a very interesting new test site by the Fraunhofer IGD and the Rostock-based Ocean Technology Campus. Peter, the floor is yours.
Thank you very much. So I'm very happy that the digital OceanLab made it to be a technical showcase now. So we made a big step forward now. So it would be really good to have the slides, and we could start with a presentation. First, to me, my name is Peter Menzel, and I'd like to show you something about the digital OceanLab. It's a test site for underwater technologies, and also with an UXO yard, or planned UXO yard. You see here the Ocean Technology Campus is also called. So we just to get an overview about this, what happens in Rostock. We have a land-based infrastructure. We call this Ocean Technology Campus. That's an institution or a corporation of the university, Leibniz Institute for Ostseeforschung, Fraunhofer, and several other players and industry. So the Ocean Technology Campus is a land-based infrastructure for all the things that's happening in Rostock. And the seaside infrastructure will be the digital OceanLab. So as we are a or computer graphics institute, it must be, of course, digital. And you see here a very nice picture with a lot of opportunities or things you could do there. And this digital ocean lab is not just digital, it's also a physical ocean lab. And here you see the map, the map close to Rostock. We have a seaside close to Rostock. It means about 6 miles, nautical miles east of Rostock with a fishery protection area. This rectangle here, this rectangle is about 1 × 1 nautical mile. And in the middle you'll see a small rectangle, a blue rectangle, where we have artificial reef at the moment. And this artificial reef, this is not UXO, what you see here, all these things, this is concrete. These are concrete tetrapods and rings and a lot of things and natural stones. And within this area, a lot of research is going on since 20 years about. And now this is, well, we have this in a cooperation with Fraunhofer using this for some time now. And we also have some experiments running there about 3D printed reef elements, a data logger test, subsea frame tests, or several moorings for fouling probes and UV light aging tests. So there is also already things running the experiments. And we also have in the communication and energy infrastructure. It's our platform, the yellow one on the left side, where you can come with your technology, your sensors or your probes and connect this to the platform. You can get all the data transferred to the land and also get energy from this platform. And so you have a lot of infrastructure for all the experiments you're planning to do. And we have a very long time history of environmental data there. So since 20 years, this area is monitored by biologists, and the seafloor and all the habitat is known. So if you're doing experiments there, we can support you with a long time series of information on this area. And what we are planning to do, we are planning to extend this. So it means, as it is already existing, the requirements are very various. So as you see here, there are ideas about a cable yard, a pipeline yard, UXO yard, and a lot of different gardens about AUV testing areas. And so we like to extend this area, make it a bit bigger, so that we can address more, more questions, more issues, and with a lot of additional sensors and so on. And that's a running progress at the moment. We have a lot of funding for this. I say a lot means we have funding for this, and we have funding for this, and we now ask you to support us with your requirements. What do you like to have there in this yard? We have a very good idea about what we are planning to do there, but within this context, Munition Clearance Week, we like to ask the industry, what are you, or what do you need? What exactly do you need? So not a rough idea, UXO yard, but more exactly. So please come to me, tell me what you need, and we will build this there for you. So the plan is to have the first usable UXO yard infrastructure in 2022, so it means in next summer. It's very ambitious, but we have good partners, IKSR, who is now likes to start building this, but we need your support to what do you really need. So our infrastructure at the moment, we have some data infrastructure, so we get all the information, context information from the platform, like video, ADCP data, wave data, and so on. And we have our vessels, so it means our own small vessel with a very new multi-beam echo sounder from McCartney now. And we have access to big technique like an ROV from Baltic Divers, or another one, a very new one from MH Weert, a crawler. It's a very interesting thing. Maybe Dieter Guldin will tell us about his experiences with a crawler. This is one technique that was developed for subsea mining once, but now we are thinking about using it for other purpose, maybe for UXO cleaning. This one is a really big one. It's about 16 tons at the moment, but this is just the model. The original one is bigger. And this is a really strong tool at the moment. They have a lot of technique on it to scan the environment, to measure what happens with the object. You can change the chassis of this crawler. You can have different sensors on it. So we have an AI on it, so that you can control it and that the object can really map its environment, and if there's an accident, it goes back. So it's an interesting tool. If you have questions to this, MH Weert is willing to answer these questions. You can also ask me. I give you the contact, and it goes through us. So why Digital OceanLab? So as we are an institute for computer graphics, you see that we are specialized, or the IGD is specialist in data analysis, artificial intelligence, and visualization of data. As you see on the right side above, if you have complex data from maybe a big dump site or from the sea ground, we have possibilities to visualize this. We have artificial intelligence to analyze the data, and this can help to improve the processes. And the other thing we are now planning to do, it's not existing yet, but will be the next thing in this development, will be a complete digital twin of the Digital OceanLab, including the fluid mechanic interaction, means a real-time interactive simulation of this environment. That's not coming today, not tomorrow, but that's for the next years. And what already is existing at the moment is a dynamic, some ideas for a dynamic room use. So we are using an ATON system, it's an AIS, as you know from boats, from vessels, they have an AIS system on it. So you can mark the edges, especially here of our Digital OceanLab, virtually via this AIS system. And as soon as we start construction, as we are doing now in 2 weeks, then we can change these buoys virtually without changing them physically. And when the construction is done, we just move it back. That's not rocket science. But we are on a way with the authorities to make this possible, that things like this will work, which also may be a good idea for further use of AUVs in a legal way. So that's just a first approach on this. So I have a take-home message for you, because my time is not, I have a lot of time, I was too fast. So a take-home message for you, as we are ready for action. So if you have any questions regarding tests, or if someone comes up with, I do not know how to remove the UXO, we can test this here. No problem, just come to us, we can test it, we can do it. So there's no way to wait, no reason to wait. And contact us with your individual requirements. We're very happy to help you with our knowledge and the infrastructure. And here you see my contact data. And if you have any comments, please just contact me. Thank you very much.
Yeah, Peter, if you have time, please, we can still bear 2 minutes maybe for a quick question, if there's one directly from the room. Otherwise, I thought this was a very interesting insight of what you guys are building up there. We heard a lot about the direct preparation on a pilot to do something, but I think there will be still a lot of research to be done, and your test site will be an excellent thingy in the vicinity here of just around the corner, if I may say so, as a Kiel-based company in Rostock. And this cooperation between Kiel and Rostock can benefit from this quite strongly. So I see a question from Professor Maser.
Okay, is this working? No. Peter, are you working with dummies then, or are you allowed to work with real munition compounds then? Let's say TNT and chunks of TNT. So it is dummy work then?
Yes. So no real chemicals, please. So and no explosives on my digital OceanLab. We can have dummies and all these things, but with the real explosives, I'm a bit careful. I'm not allowed to do this, I think.
Okay, but I understand you plan to be ready for action in summer 2022, already in a year's time, and now would be the time for sharpening your concepts to speak to many other business stakeholders what they would need.
Depends, yes. So it means for the UXO yard, please come with your information or your requirements. But if you have other tests, normal underwater technique like testing underwater acoustics or who knows? So whatever you have on your mind, we can do it now. The areas there, the digital OceanLab is existing, and we can work there. We can just start.
Perfect. So I think there will be plenty of use cases soon coming up, I can imagine, and you will be with us here. So if there are some further questions, please approach Peter on this very marvelous endeavor with the digital OceanLab. Good luck with this. Thank you very much. So I quickly move over to our next speaker, who is with us this time from Zoom. This will be Bert Kearney. Bert, are you there? I hope so. I saw him briefly on the monitor. So I start already introducing Bert. You guys will put him back on the monitor, please, again. Bert Kearney is Managing Director of Dynasafe Environmental Systems here in Germany, and also Executive Director Operations on a global scale. Bert is deeply involved in EOD for more than 30 years in more than 25 countries already, and his work is related to conventional, same as chemical ordnance, both on land and offshore. And the name Dynasafe we had heard before also already in conjunction with the platform of ThyssenKrupp. So it would be wonderful to have him here with us. If somebody just could give me a quick sign. If not, we could maybe otherwise move over. Bert cannot make it. So Dieter, if you are ready, I will just swing over to you. Dieter Guldin, COO from SeaTerra. We had the pleasure already to have you on the stage yesterday, and you already predicted that you will have a more or less what was status yesterday, and you will share with us a little bit an outlook in what you guys are working on right now. I'm curious. The stage is yours.
It was a bit of a cliffhanger yesterday I created, yeah. Thank you very much for being back, having me here. Actually, just let's start this way. A snowflake is a brilliant thing. It's very complex and it's fascinating. And a walk in the winter forest, in the Black Forest, is also very fascinating and romantic. So, avalanche in the Alps is a disaster. It's a catastrophe. But you know, it's all frozen water. And the difference is just the amount of frozen water. So if you have a bit of a pragmatic approach, if you look at the disaster, if you look at the problem, it's just a question of the mass. So the difference between a snowflake and an avalanche is the amount of snow. So the difference between a bomb and the difference between a dumping area is the amount, actually, which makes it difficult. But it still is frozen water. So that's the way we look at it at the moment. So for us, it's a problem of technique, equipment, logistic, to scale up things, to speed up things. And that's actually what we thought should be in place for addressing dumping areas. And that was the reason why we've started to work on a crawler system or crawler-based system 2 or 3 years ago. So, like I mentioned yesterday, we had a project. It's called Menzel Oak Project, and we've been working for the Wasserschifffahrtsamt Wilhelmshaven. And I would like to thank the Wasserschifffahrtsamt Wilhelmshaven and company Agarius, who was actually accompanying us and on that project, that they have been willing to give up the chance to step up to show, so that the crawler might be an option, might be a solution to the problem. So what's special at the Menzel Oak project? Like I said yesterday, actually nobody is building something in a dumping area. That's actually the reason why we get not rid of the UXO, because we do always the workaround thing. So, but in this case, it's slightly different because there's the shipping route going out of Wilhelmshaven, and the shipping route has a curve, and you see where it's mentioned Arbeitsgebiet. There's a slight curve, and the curve is actually too narrow. And the problem is for the big vessels from the Weser port, they need a wider curve to sail around there, and just in the curve there's a dumping area. It's a dumping area which was expected to have a lot of sea mines in, ammunition, different type of mines. So we are in front of Wilhelmshaven, we are in front of Wangerooge, and that's actually the area. So based on the magnetic data, and we also did electromagnetic survey. It's not our data, by the way. So we got the data already, and but we did with a new electromagnetic system another survey, and it was quite corresponding to each other. So the data set. Based on this data, we've been invited to come over for the clearance of 100 targets. And who is familiar? Those who are familiar with Menzel Oak know it's a challenging area. So what do we have? We have current, very high current, 1.5 meter per second. We have 2.5 to 3 knots sometimes on the surface. 2.5 knots on the seafloor. And those who are familiar with those numbers know this is really something. We have water depth of 15 to 25 meters. And we have the shipping lane just next to the working area, which means actually we cannot go on anchors. We have to have a stable platform or a DP2 vessel in place. And since we decided to work with the crawler, or to offer the project with the crawler, we decided to have a checkup barge in place. So it's a very challenging area. And so to say, I mean, I discussed it yesterday with Buskalis here. It's if the job wouldn't have been at that corner, let's say it would have been in the Baltic area, it would have been quite more smooth going, easy going. The corner is really challenging. If you can it there, hopefully you can it everywhere. And so I'm not talking about the problems we had on the project. I'm not talking about tracks falling off the crawler. Yeah? I'm not talking about off time, which raised a huge amount of costs, to be honest, yeah? Because I want to sell you the good picture, the nice picture, yeah? Smart things. Yeah? So one machine, 4 different tasks. We have relocalization, dredging, identification, and clearance by the means of picking up UXO, placing it into a basket, lifting the basket up. So all those all those 4 steps are a kind of obligation to every clearance process. You cannot work around it. Yeah? You have to do the relocalization, the dredging work, the identification, and the clearance. Yeah? And we've been focusing on identification very hard the last few months. So we've been focusing on attaching a magnetometer sensor, to attach the side scan, the sonar to it, a Gemini, a Blueview, an ARIS system, ordinary cameras, all kind of different things, yeah, to get somehow a picture. What are we coping with? Because if you don't know what you're coping with, if there is not a 100% clear identification, no chance to step further. You know, there is a certain kind of process of clearance which has to be kept, yeah? And the identification, the decision making, if it's safe for transport on land, do we have to blow it up, is based on the clear and 100% identification. So that's the machine. It's a cooperation between a Norwegian company and SeaTerra. It's called Deep Sea. It's 15 tons on air. It has a lot of cables. It has a lot of pipes, a lot of valves. Yeah, and I can name them one by one because they broke down one by one. And as you can see, it has 2 arms. Yeah? The 2 arms has been actually. I mean, once we did our test, it was clear you cannot do it with 1 arm. We need 1 arm for survey, attaching the magnetic sensor on it, which is actually a gradiometer system with 3 different sensors in. So you can have a smaller distance and a wider distance. And you work on all 3 axes, X, Y, Z. Yeah? So actually that was the idea. And the front part was from aluminium and Edelstahl just to get rid of most of the noise. And there was a lot of time spent on how sensitive is the magnetic data. Because going back to the relocalization, you really need to find the target again. And so that's what we did. We put a sensor on it and it worked. And we attached to the same arm the dredge pump and some cameras and ARIS system in order to be able to pinpoint the target, to work with the dredging pump around and to see where we are. And then we have the second arm, which is actually, which needs to be capable to pick up a 250, 400, 500 kilo objects, because we found mines with an anchor stone, which is quite complex to lift, but we've been able to manage. So 15 tons on air, 2 arms, remotely controlled, 3 days work without launch and recovery, and this is a good one. Yeah, I'm coming back to that, and stable working platform until 2.5 knots. What's the idea behind? I mean, if I say 3 days working without a recovery, the most of you will think, I'm working the whole week without launch and recovery. So what's about 3 days? Actually, the problem with the RV is you haven't got a stable platform in the water. You need to launch and recover it. Yeah? You have to wait for the tidal window to get a new approach. So if you do a hole with the RV and the tide comes back, it's probably a lot of backfill in there. So you have to start the process again. So what have we been looking for? We've been looking for a stable platform which can drive on the seafloor and probably for 2 or 3 days. So this is actually what we see, a 3D animation, not of just fiction. This is what's in the office. Yeah? So we imported the multi-beam data and all kind of data into the platform, and this is actually orientated. So this is real data based on the coordinates, and on each position we have to clear we made this stick with the number on. So based on the multi-beam data, we have been able to drive on the seafloor because we know, okay, it's going up, it's going down, left and right. And so that's actually the virtual reality on board, yeah, how to operate this thing. So what you see over here is ARIS data, and I mean, we did not invent ARIS, yeah, and everybody knows ARIS system who's working on the seafloor, but it was amazing, yeah, what I've seen there compared to the camera, to the picture, whatever. Let's see if that works. What you see on the right-hand side, yeah, is actually this claw. It's the moving crane arm picking up a grenade, and what you see in the left-hand side is 2 mines already laying in the basket. So let that run for some seconds. Yeah, you won't probably find out where is the grenade or where is the target. Yeah, you will see the claw closing, but actually there's something different I want to show you, which is just coming, hopefully within a few seconds. It's actually the situation compared to this ARIS system on the camera. So. And for our specialists, it's also, for our EDs, it's also very difficult to get used to that 3D thing, yeah, to find out where it is. But can you see the current and the kind of snow, or so to say, in the water? Yeah, I mean, that's reality there. That's part of the reality there. I mean, look at the speed. Look at the density. With just a normal camera, you couldn't do anything. So that was actually the idea behind, to have different kind of visual sensors in place in order to be able to identify and work. And that's actually the snowstorm we faced down there. But then we've learned also, and this is a very site-specific thing. Yeah? Please keep in mind, everything is very site-specific about OCSO clearance. Nothing is just like one job is just like the other. Yeah? So it's very site-specific. We learned with the water coming in to Wilhelmshaven, we had this snow thing going on. With the water, we had almost good visibility. With the water going out, we had all these sediments in the water. So once we haven't been able to identify clearly a target, we simply left it in place, yeah, and we waited for the next tide. So water going out or water going in was actually a crucial point. So what you look on here is two mines on the seafloor after picking it up by the crawler, putting it in the basket, and now lifting it up into the basket. So this is the basket with our net, and it was clear we have to deliver the full picture, we have to deliver the full service. So we pick up targets, we bring them up to the seafloor, we sail to the sandbank, or we sail to the harbor in order to hand over the ammunition to the authorities, to the Kampfmittelräumdienst. And it was quite tricky. It was quite a task to invent something, yeah, like those barkers, which are able to be filled up on the seafloor, lifted up to the surface, transported to the sandbank, opening the basket, and only the net and the mines remains on the sandbank. And we've ordered a special kind of net, which is quite expensive, to be honest. One net is about 480 euros because it's only Baumwolle and basalt, so it can be detonated, nothing is left. Yeah. What we used for that was a system, a catamaran in the catamaran system. Yeah, so we bought a catamaran, and we produced a smaller catamaran, which is actually the smaller brother. Yeah, so a bigger catamaran, smaller catamaran, and the small catamaran has a winch. It has cameras. It had different kind of sensors, and it has a remote control. And the bigger catamaran also has a winch. It has cameras, so the full set. So what we do is actually we have the small catamaran in the big one. We have the basket attached to the small catamaran. And we are able to lower the basket to the seafloor, and we are able to pick up the basket again as soon as it is filled. We can leave it on the seafloor for a week. suppose it's not probably that much of a good idea. You become quite nervous, yeah, after a while. Yeah? So is still everything is in place, yes or no? So this is the main basket system we've been working with, but we had also other baskets, just ordinary subsea baskets, which also fit into the system, yeah, where we delivered actually the ammunition which is safe for transport, handing over it to the KBD. So this is a picture from the bigger catamaran to the smaller catamaran, because once we had something in the basket which was not safe for transport and handing it over to the KBD, we had to bring it to the sandbank. So we lifted it up in the smaller platform and we towed it behind the bigger catamaran to the sandbank, doing a curve. And as soon the smaller catamaran, which has also a GPS system in place, lowers the basket down, the net will just be lowered to the sandbank and lift the basket up. Everything is free and you go. It sounds easy. I've spent weeks to find a simple mechanical solution. I don't want to have hydraulics. I don't want to have electronic. I don't want to have anything which can go wrong. I just want to have simple mechanical solutions to solve this problem. So what have we done in the end? We've surveyed, we cleared 8-8er, 10-5er, 12-8er, Kampfmittelschrott, Artilleriegranaten, Minen. So we had in the end 28 flak, 8 mines, 1 BMC mine mit Ankerstuhl, which was quite challenging, Metallrahmen and Grundgewicht. And if you remember my presentation yesterday, where I said, okay, we do scrap removal, or are we doing actually OCSO clearance, or do we scrap removal? This is actually what I'm talking about. Actually, 69% of the targets we've cleared over there is UXO. So this makes the difference, yeah, if you work outside a dumping area or inside the dumping area. And from efficiency, yeah, I would say it took us quite a while to get these UXOs out. And we learned a lot. We had a very, very flat learning curve the first 2 weeks. Yeah. And many technical problems. Yeah. And so it wouldn't be fair to say, it took you 6 weeks to get that stuff out. That's not an efficient process. Yeah. But if you look at the other way around, yeah, if you say, look, actually this has been a proof of concept for us. I mean, it was in our mind, it should work. We haven't had an idea. Yeah. So we've been actually looking for a proof of concept. And after the first UMA mine in the basket, lifted, transported, and blown up by Hans Mohr, it was a kind of hurrah-ing, because that was the proof of concept that there is a kind of game-changing thing. Yeah? The first time somebody cleared a mine, yeah, with a crawler, proving that this arm thing, relocalization, dredging, identification, transport is able to work. So actually, this is a basket which has been delivered to the KBD on board of the bigger catamaran, because these kind of UXOs, they can be handed over to the KBD. I mean, they are safe for transport. So keep in mind, not everything on a dumping area is actually meant to be blown up, yeah, or just put it into the oven. By the way, yeah, I mean, even has everybody spent a thought if we can use UXO as a kind of energy source, put it in the oven, not for just burning it, investing energy, but getting energy out. Yeah, I mean, you say yes, yeah, very good. Yeah. So, and we handed it over to the KBD, and they took it and drove it away. I mean, if you remember the numbers, 57 grenades, something, and just a bit of scrap metal from UXO. And that's actually what we did at Menzel Oak. Yeah. That was the project. It was a very challenging project, yeah, which required Teams meeting from 3 o'clock at night to 5 o'clock in the morning. Yeah, just picking up the phone and say, okay, let's come on the phone, yeah, or let's come on the computer. But we've learned a lot. Yeah, we've paid a lot. We've learned a lot. But at the end of the day, I mean, we found out this system as a proof of concept is working. And I know there are now some questions in regards to TKMS. And I mean, the colleague before, they said, okay, SeaTerra has a different idea. It's not about a different idea. It's simply a different kind of aspect, yeah, because you have to be clear on the situation that the platform is not a solution to the clearance. It's a solution to getting rid of the stuff in the end of the process. The process of UXO clearance is still something which has to be highlighted. Yeah, so I mean, if somebody is happy to spend some money for us, yeah, whatever, yeah, so we'll go to build 3 new crawlers based on our experience over here. Yeah, so I'm happy for people coming up later. Yeah. But to be honest, I mean, it's true. Yeah, the amount of UXO we're talking about needs a solution. Yeah. I personally would advise to have a kind of alternative thing in mind. Yes, starting with a smaller project, getting rid of UXO, starting as soon as possible, bringing it on land and to the KBD, and in parallel build up probably that the platform. Yeah, we've been talking about, or we've heard about so oftentimes. Yeah, but get experience. Get something involved, yeah. Get the companies involved to do the clearance and to start right now, yeah. In order to get experience. And don't forget what I've said yesterday, or please, I mean, just remember, we need the specialists. If we don't train the specialists in Dresden, for example, yeah, bringing up courses for offshore EODs, we won't have them at a later stage. If you work in 3 shifts on such a platform, if you have to address the amount of UXO, you need a specialist for them. Yeah? So at the moment, Baltic Tower, Boskalis, Hirdes, Eggers, whoever is on the market, yeah, we all train the guys. And after 2 years, 3 years, they are able to do the job on the platform, probably. It takes a long time to train them. Yeah? And so keep in mind that if the process has to be started, it has to be started on different corners, yeah, and also for the EOD services for the Kampfmittelräumdienst on land. Yeah. Well, actually, I'm not sure if I took too much time, but that was it from my side, and I'm happy and proud to present it. Yeah.
Thank you. Thank you, Dieter. Bert Koenig couldn't make it with us. His computer broke down, so you used the time very
wonderful.
good, I think.
I mean,
if you remain,
what a mess, yeah.
If you remain for a couple of minutes with us, maybe we also have some further questions to it. I do have. This was very nice to see this project you had. We talked a lot about a pilot, and this pretty much was yours.
Yeah, I mean, as a matter of fact, it was a bit under the radar of the most of the people. Yeah, yeah. Probably. I mean, Klaus Böttcher was somehow involved. Yeah, and knowed about it. And I mean, this is what I said. Yeah, I mean, the Wasserschifffahrtsamt gave us the chance, yeah, to step up. Yeah, and I mean, this is a really important point. Yeah, I mean, if we wouldn't have had a chance to work for the Wasserschifffahrtsamt, yeah, I guess we wouldn't have been able to do the job for a commercial company like whoever, yeah, Tenet, Vattenfall, because they are so strict. They are focusing on the VOB, yeah, they are focusing on the Vergabeordnung. And after our first few problems on board, yeah, they would probably picked up the phone and called the lawyer and said, hey, something is going wrong, yeah, I mean, we should better stop them. No, I mean, that was the freedom we had to work, and we sometimes need the freedom for innovations here. We need the space and the freedom on such project for innovations, otherwise it can't work. It won't work.
So when did you start working on your crawler idea? I mean, the Wasser- und Schifffahrtsamt didn't just ring you up and you had it ready.
We in 2018, I guess. Yeah. Okay. I mean, my agenda was pretty clear. I want to get rid of the UXO dumping areas. SeaTerra is not able to offering a system so far. So what's needed in order to bring something to the market, and we looked around. I mean, we have our airlift, we have our grabs, we have our sensors. I mean, that's all nice. And at the end of the day, like I said, it's not like you've got one thing for the whole picture. The crawler wouldn't work in Hamburg. It would get stuck in the mud, and that's it. Hey, good night crawler. Yeah? You can't drive anymore. So what you need a multi-tool over there, or you need an airlift or whatever. Yeah? So, you know, the industry is going to offer a range of possibilities to different kind of questions. Yeah? And the answer has in accordance to the question. Yeah? So that's a bit of my problem with the platform. Yeah? The platform won't be probably the answer to every kind of situation. Yeah? But that's not on my table, that's on the table of the engineers. Yeah?
But it could be an answer to many other situations. And
Exactly.
I heard also that it could be an answer to the disposal problem we have.
Yeah.
I mean, you can start, and I see that this is all about good timing. You had started early enough in 2018 already, and then you came to the chance with this pilot project that you could do your proof of concept.
Definitely.
But at the same time, you still bring a lot of the remnants back on land, and that in future we face issues on the disposal time. Maybe the platform can help too. Is there any questions from the audience, maybe to Dieter? Yeah,
So everything is clear, it's brilliant.
I think, we just need the command to go. Yeah?
Okay.
So we're
Thank you very
looking for
much.
more pilots, and I thank you very much, Dieter,
Thanks.
for this intensive insight into your project. And I hand over to Terry, luckily. I say goodbye to the audience with the technical showcases, and Terry, stage is yours. Thanks.